Hello student, in this video lecture we are going to see the analysis of indeterminate structures by stiffness matrix method. It is one of the method of displacement method. The first thing, we are going to determine the degree of degree of kinematic indeterminacy of the structure or degree of freedom of the structure. Then second step is assign one coordinates in the direction of each unknown displacement, and also develop the stiffness matrix for the assigned coordinates. The number of coordinates will be equal to the degree of freedom. So in the second step, we should assign the coordinates for each unknown displacement. Okay. Then develop the stiffness matrix for the assigned coordinates. The order of the matrix is equal to degree of freedom. Then third step, restrain the joint displacement in all direction, and let the forces or moments recover or develop due to applied loads in the restraint structures in the direction of assigned coordinates be p1 dash, p2 dash up to pn dash. So in the third step, we should restrain all the joints. We should restrain the joint displacement all the direction. That means we should give the fixity, all the joints of assume all the joints are fixed joints. Then determine the force or moment developed in the assigned coordinate direction. So it can be represented as p1 dash, p2 dash up to pn dash. In the fourth step, remove the given loading. Now supports or joints are released or unlocked by permitting deflection at assigned coordinates. This displacement requires forces p1 delta, p2 delta up to pn delta at coordinates 1 to n. So in this step, in the fourth step, we should remove the given loading and supports or joints are released by permitting the deflection at the assigned coordinates. Then determine the forces p1 delta, p2 delta, p3 delta. So this is determined from stiffness matrix. Thus the p1 delta is equal to k11 delta 1 plus k12 delta 2 plus so on k1n delta n. P2 delta is equal to k21 delta 1 plus k22 delta 2 and so on plus k2n delta n. Then Pn delta, general equation Pn delta is equal to kn1 delta 1 plus kn2 delta 2 plus so on kn delta n. The finally it can be represented in matrix form. P1 delta, P2 delta up to Pn delta is equal to stiffness matrix times displacement. P delta is equal to stiffness matrix into delta. The final forces in the direction of coordinates will be, P is equal to P dash matrix plus P delta matrix. So this is equation 2. So previously P delta is equal to K into delta is equation 1. So substitute equation 1 in equation 2. So the final force P matrix is equal to P dash matrix plus K matrix into delta matrix. Finally K delta is equal to P matrix minus P dash matrix. Finally delta displacements is equal to stiffness inverse matrix into total force matrix minus P dash matrix. If the external force at the coordinate direction is 0, then P matrix is equal to 0. So finally displacement matrix is equal to minus stiffness inverse matrix into P dash matrix. The step 6, knowing the joint displacement, compute the moment by using slope deflection equation.